So for today, it is about sine, cosine, tangent. Actually, not tangent today. It's too complicated. But we'll do sine and cosine. And we're going to be talking about all these things like domain, range, period, amplitude. And I am going to jump right into it. You do not have this slide because I think the teacher felt like you should build it yourself. But I think it's really helpful to see the big picture. So sine is a wave, and one of the things you have to understand is the difference between sine and cosine. Do you get they're both waves? Do you get they both go as the same exact height as each other? If you haven't processed this yet, look at how high it goes. And the distance from zero up here, that is called the amplitude. That's how high the wave is. Can you stretch sine to look like this and go twice as tall? Yes, you can. You can do that. Then it would be 2x. It would have a 2 in the front of it because it would be twice as tall. It's like multiplying all the y values by 2. All right. Another thing that's important is that you by now have started to think in terms of radians. So 360 is pi. No, wait. 180 is pi. Sorry. 360 is what? 2 pi. Good. And then half of pi would be pi over 2. And I like to think of it that way. This is halfway to pi, and then there's pi. And then I think you should count this way. 1 pi over 2, 2 pi over 2. What do you think this spot will be then? 3 pi over 2. See how it's so logical then? And then you might be like, yeah, but that's not 4 pi over 2. Yes, it is. 4 pi over 2 is 2 pi. Okay, so you count them that way. 1 pi over 2, 2 pi over 2, 3 pi over 2, and 4 pi over 2. All right, what's the difference between sine and cosine then? Well, it's where the peak is. This one starts at 0. So sine starts at 0, and it goes up. Cosine makes a big valley. I was just in Colorado and had a chance to ski at Breckenridge. I've never done that before, and it was so cool. The skiing was just so beautiful. The sun was shining off the freshly, it had snowed big time out there. Anyway, it was a valley, and I was skiing, of course, down the mountain, and then the bottom of the valley is where the city of Breckenridge is. All right, so anyway, cosine is like a big valley. Tangent looks completely different. I mean, it's like completely different. And we'll talk more about tangent on a different day, but tangent is one that has asymptotes in it because tangent can't exist at certain spots. Do you remember on the circle trig that tangent, sometimes you'd have 1 divided by 0? Does that ring a bell? Because it was y over x. That's why. Because see this asymptote here? That's when you're dividing by 0. Can't exist. Okay, so there's the big picture. You're going to have to graph sine and cosine by the end of today. Eventually, you'll have to know how to graph tangent. So this page, please. So we want to connect this to something you did before, the circle tree. Do you remember that if we were going to do sine at this spot, it would be the y value over the r value, but we're going to keep your life simple. Sine is y over r, but we're always going to make r equal 1. So then what does sine turn into? If r is 1, do you get it's pretty much just y? Sine is y. It is y over r, but if we make the r 1, then sine's y. And then what's cosine? X. And then tangent is y over x. Sine's y, cosine's x, and tangent's y over x. All right, so I thought you used to say it was y over r. Yeah, but we made the r be 1. So it's like y over 1. So we'll just call it y. All right, so back to this spot. Sine is the y. So at this spot, sine of pi over 2 is the y. So it's 1. So if we were going to make a graph of it, we could actually use this to make the graph. If I just want to focus in on sine, then I'm just going to focus in on the y values, and I can say that sine should start at, here's the y value of this point, Sine should start at 0. Remember me saying sine started at 0 and then it goes up? Cosine was like a valley, so it started up high and it goes down. But anyway, sine starts at 0, then it goes up to 1, and then sine is the y value on all these places, so then it goes back to 0. See what's happening here? It's going up to 1, back down to 0, and then it's going to go down here, and the y value at this spot is -1. It goes down to -1, and then it goes back up to 0, and that's why it keeps going. Sine keeps going forever, and just like it just will keep on going. We usually only graph one period of it. Oh, I should talk about that. That's like a complete cycle. So that's the part of sine that we keep graphing over and over again, even though it goes in both directions, like it goes left and right. But that is called one period. It's like one complete cycle from beginning to end. And it starts at 0 and it ends at 0, and so then it's done. All right, so that's called the period. I already told you the name of this little thing. Who's got a short-term memory? That thing is called the amplitude. Very good. That's the amplitude of the graph. It's how high it goes from the middle line up. Did you know that actually there's debate amongst surfing experts on if your wave should be measured from the bottom to the top, or if it should be measured from the middle of the wave to the top? Because some people say it one way and some people say it the other way. We in math always use from the middle, that line right here, to the top. That's the amplitude. It's almost like if the sea instantly like calm, like just like boom, it went flat calm. Do you get this part would come up and this part would come back down, and then it would be like this is the sea level right here. And so it's only the part that's above the normal sea level that's the amplitude. The reason I'm talking about this so much is kids always think it's this distance. That is not the amplitude. That's double the amplitude. The amplitude's only from the middle up. Okay, good. So we got a few words down, I think. The period is like from the beginning to the end, and they say, how long does it take to do that? 2 pi. That's actually like a distance. It's like from 0 to 2 pi. So it's like sort of like a time in a way. It's the amount of time it takes for the graph to get back to 0 again is 2 pi. All right, another thing I got to remind you about. Do you remember that when you had a graph like this and we put a 3 or a 4 on the inside, that it does the opposite of what you would expect when you're on the inside? That's going to matter again because you're graphing and you're graphing trig, and you got to remember that deal where it doesn't do what you expect. You get that 4 seems like it should make it 4 times, and this is the horizontal on the inside, 4 times wider, but it doesn't. It makes it 4 times narrower. So the graph will be like really narrow, like really tight. Okay, so if you put a 4 on the inside, or any number that's bigger than 1, the thing's going to do the opposite of what you would expect. All right, so what if I took a graph like a quadratic, but I put a 1/2 on the inside? Oh, that should make it half as wide. No, it makes it, what's the opposite of half as wide? 2 times wide. Does that make sense to you? So if I'm talking about sine, and I say y equals 1/2 sine of x, but wait, it's not got to be on the inside. It'd be like this. Then that's going to not make it half as wide. That will make it twice as wide. Stuff on the outside of the function is like out here. Do you get that we can trust the stuff on the outside, just like we could before? Just like it was on the outside of y equals, x squared, and then there was like a 3 in front. Well, it was 3 times taller. It was easy. This, it's 2 times taller. And that's where the amplitude goes. Okay, so if you ever want to know the amplitude for sine, cosine, or tangent, just look at right there. The number that's right there, that's the amplitude. All right, and then there's one more little formula I want to give you that's really important. You should write it down. It'll improve the probability you remember it. The period is 2 pi. We already knew that. I said it out loud, but then I got to tell you something. Divided by b. What the heck is b? That's b. The period is 2 pi divided by b. So, if you tell me b is a half, then I would stick the b right here. And have you learned enough about fractions from my first 20 thing to know, oh yeah, I just flip and multiply that. Do you get it's going to make it twice as long between the marks? Because you'd think it would make it half as wide, but it makes it twice as wide. And that's this little formula at work. The period is 2 pi, but you divide by whatever number is there, that's b. And if b is a fraction, you do the opposite of what you would think. It doesn't make it half as wide, it makes it twice as wide. Because if you go and multiply this by, times it by flip it, it'll make it times by 2 over 1. Okay, so there was a ton of stuff. If I just said graph sine, I have a feeling you would not do that great yet. But I can, so I'm going to show you. Sine starts at 0, it goes up to 1, and it comes back down again. And then I think you saw it, and therefore you probably know it goes down all the way to, what do you think it goes down to? -1. And then it comes back up to here because it's completed a whole cycle, or what? Period. In math, we call it the period. And it ends at 2 pi. And this is half of that, so that's pi. And this is half of that, so it's pi over 2. And then I said count by 1 pi over 2, 2 pi over 2. And that helps you remember that spot. 3 pi over 2. There is sine. How high did it go again? 1. And how low did it go? -1. So, if I said, looking at that picture, what's the period? Say it if you know it.
2 pi.
2 pi. Because it starts at 0, goes to 2 pi. What's the highest it ever went? 1. From the middle up, that means its amplitude is 1. Okay? So you got period down, amplitude is this part. And now if I threw in a 4 here, it wouldn't make it 4 times wider. It would shrink it and make it 4 times narrower. And just I'm going to change that to a 2 just because it's so much easier to make it half as wide. Then it would make the complete cycle finish by there. It's like, I made it shorter though. I didn't mean to make it shorter. Here. Same height as it was, but it's got to finish by here instead. There. It's about the same height, and it finished twice as fast. It's narrower. The red one looks more stretched out comparatively. All right. How about cosine? Everybody write y equals cosine and make one of these. And I said cosine was like a valley because I said it was like Breckenridge. So where do you think I should start? Here? No, because that's where sine starts. At what? At 1. Very good. And then I like to think of it as having 4 parts. First it has to go down. And then, of course, it's going to keep going down all the way to 0. And then it's going to go back up. And this last part's the weirdest part. Got to make it kind of like crest right there. It's like a big valley. That's cosine. Now take a second and use your brain and figure out what you think goes here, 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 and here, and here. And I already labeled that spot as 1. I bet you can get the rest of it. And that's cosine. Label those 4 spots. This is your happy place. This is home. If you're going to survive your next math test, you're going to have to be able to graph regular cosine in your sleep. It's got to be like, oh yeah, duh, graph regular cosine. And then from there, you go like, oh, now I have to stretch it, and now I have to shrink it, and now I have to do other stuff. So if I was your dance teacher in this, it would be like, you just learned how to do a, I don't know, some basic dance move. I suppose a pirouette, like you spin around. You done? Yeah. On my keyboard up there is good. And now you have to put that into a whole routine with other stuff, but you start with this. I'm going to call on different people, and I'm just going to ask you simple questions. If you don't know, I'll help you. Based on destiny, who should I call on? It's... Person 2, Garrett, that's you. What is at the very end right there?
2 pi.
2 pi is correct. And half of that would be pi. Weird. You again, Garrett. Probability of that is very small. But would you tell me these other ones?
That would be, the first one would be pi over 2.
Pi over 2, or half of pi. And then I encourage you to count 1 pi over 2, 2 pi over 2. What's the next one? 3 pi over 2. But that should be 4 pi over 2. Yeah, because 4 divided by 2 makes 2. The reason I think that's so powerful is because imagine for a second that I asked you to tell me the next spot right there, right after 2 pi. It's a pain in the butt, unless you count the way I said. 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, duh. See how it's 5 pi over 2? That's why I want you to do it that way, because if you count that way I just showed you, 1, 2, 3, 4, duh, it's 5 pi over 2. Otherwise, you're going to be like, I don't know, what comes after 2 pi? Not many people are going to know it's 5 pi over 2. See what I mean? So count that way. 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. Then if we have to shift it to the right, which is going to happen, then you'll have this spot already figured out. No big deal. All right. What's the amplitude of cosine? Nope, not negative. Regular 1. It's 1. And I could put a 1 in front of it, couldn't I? So that's where the amplitude goes, is right there. No, it can be negative, but I want you to theorize. When you stick a negative into a function, what are you used to have happening? What's normal for putting a negative in the function? It flips. So then your whole function turns into this. See what I mean? I'd kind of bent mine a little bit, but it flips over if you put a negative in the front. You could even put a negative on the inside, but we won't even do it to you. It's just so complicated. We don't even do it in honors to put a negative on the inside of the function, because then it has to flip, and then if you flip this way instead of up and down, oh, it gets so confusing on where everything is. So, all right, this page, please. So, if I asked you to fill in this chart and gave you this pro tip, every 2 marks is where you should put, otherwise your graph's going to be so tiny. Go like that. And make the last one 2 pi. I bet you can put everything else on this page. I bet you can put the graph on here, etc. I bet you can label this spot and this spot. I bet you can tell me, if you think about it, though, domain and range aren't that hard. Domain is from left to right, and how far does sine go? Range is how low to how high. The period we already talked about. The amplitude we talked about. The y-intercept's easy. It's just a normal graph, so what's the y-intercept? And I never talked about continuous, but I will just tell you, because this thing goes forever, it's called continuous. The function doesn't just stop. There are some functions that do, But this one just keeps going forever. Like if you wanted to, you can go in this direction forever. And then this direction, generally to the right, it'll go forever. So therefore, yes, it's continuous. All right, now see if you can fill out the whole rest of this page. Like try to figure out what would even go in here. Sine of 0 theta. It's just a number. I'll help you with the chart in a second if you stuck with that. Row 1, person 5. Anna, can you tell me what the rest of these blue labels are, like in here?
Yes.
Pi over 2, aka 1 pi over 2. Keep going. Pi, aka 2 pi over 2. Keep going.
And then, is it 3 pi over 2?
Yeah, see, if you count it the way I said, 1 pi over 2, 2 pi over 2, you'd know for sure it's 3 pi over 2. And then the last one is 4 pi over 2, which is the same as 2 pi. Okay. All right. Next up is row 2, person 1. Isabella, I feel like the next logical thing is to finish this wave. So where does it go from here? Like it started to turn the corner. Where's it going to touch next? Or where's it going to go?
It's gonna go down from there to, I think.
I agree. It's going to go down. What's it going to touch next?
I think 2 pi.
All right. Like all the way to there?
Oh, no.
Okay,
Sorry,
okay.
2 pi over 2.
Yes, I agree 100%. There. All right. Now, row 6, last person. Spencer, can you tell me where it goes from here? We stopped there at 2 pi over 2.
It goes
Or,
down.
that's not, yeah, that is 2 pi over 2, sorry. Yes, it keeps going down until it hits.
1.
Yep.
Negative 1.
Except negative. Yes, correct.
And then it goes to 2 pi.
And then it goes back up to 2 pi. Perfect. There is your sine graph. Row 5, last person. Tully, can you tell me, domain means from left to right. How far does this go from left to right? Hint, we only graphed a tiny part of it.
From 0 to 2 pi.
That is the tiny part that we graphed. But does sine really stop on both ends? And therefore, what should you put for the domain?
Negative infinity.
You are correct. All right. Row 6. Man, it really likes you today, Garrett. What's the range? Hint, it's from low to high.
1 to -1.
Except you start with this. There you go, -1 to 1. And it touches it, so brackets. And that actually matters. You write that wrong on the test, I have to take off 5% at minimum. And that's if it was a complicated problem, that was the only mistake you made. Gotta have brackets. Why? Because it touches on the ends. Can't touch infinity, so use parentheses for that. Period. You can just give me one number, Jack. What's the period of this thing? 2 pi. Because it completes its cycle between 0 and 2 pi. Amplitude. Nate. 1 is correct. The amplitude is 1 because it, you could say it two reasons. Because we only are graphing one sine, and because we went from here up, and that was 1. The y-intercept, just think of this as a normal graph, and here's the y-axis, and then what's the y-intercept? Right there, and so it's 0, 0, actually. Does touch the point 0, 0, doesn't it? Okay. And continuous, you already said yes because it keeps going. Like, we only graphed a little part of it. Now, to me, the hardest part is just like going back and figuring out this thing. At 0. What was sine 0? Because we were at the point 0, 0. At pi over 2, which is like here, what was sine? 1. The height was 1. Remember, the sine is the y, which is like the height. At this spot of 2 over 2, which is the same as pi, it went back to 0. Wait a minute, you're giving me those zeros and ones again. Isn't that kind of like this? Yes, it is. Sine is the y. 0 to 1 to 0 to negative 1. 0 to 1 to 0. Well, what's it going to next? It's going right here, and it's going to negative 1. And at 2 pi, right there, it's back to 0 again. Get how these are all ones and zeros? You could have got them from this. Because that's the way we used to do trig, with that circle with the x and y axis going through it. It was all about this for a long time. But now we're making our graphs like this. All right, without my help, I think you should be able to graph cosine. But just so that everybody does it the same, every 2 marks. Otherwise, your graph will be too squished. So make this 2 pi. All right, I'll be quiet for a minute while you see if you can graph cosine. Remember, it's a valley like Breckenridge. So we get row 3, last person, Effie, that's you. Where should I start making my graph?
0, 1.
I agree. I'm going to put a dot up here because it starts up high and then it makes one big valley and it ends up high. So I actually kind of like the idea of telling myself where it begins and where it ends. And if it's really all just one big valley, right in the middle is where it hits its lowest spot. And I like to make this in 4 parts. 1, 2, 3, and 4. There we go. You might be a better artist than me to be able to just make that a nice, smooth, continuous line. And then halfway should have been pi, because that's half of pi. And then this is really pi over 2. And then I like to count it up. 1 pi over 2, 2 pi over 2. And by the way, this is the one unit where 3 pi over 2. If you left it like as 2 pi over 2 right here, I'm okay with that. Even though it's supposed to be pi, if you said 2 pi over 2, I get what you're doing, and I kind of like it. Same with 2 pi. If you said 4 pi over 2, I kind of like it, because you're thinking about, oh, the next line here, that would be 5 pi over 2. And that's a smart way to think, so I'll let you leave it as 4 pi over 2 or 2 pi over 2 without any penalty, because I don't want to penalize you for doing something I suggested. All right. Then we have these a whole bunch of questions. Domain. Claudia, the dice have been generous to you today, so I'm calling on you anyways. Domain means left to right. How far does this thing go? You are correct. Negative infinity to infinity. The range. Row 2, person 1. Clara, that's you. What's the range?
-1 to.
You got it. -1 to 1. And it's got brackets because it touches there. Riker, what's the period?
2 pi.
Yep. The amplitude, Mason. It's like this.
1? Or
Yep.
1? Or
Just
just 1?
one.
Alright.
Just one. We can put a -1, but it would flip our graph over. All right, the y-intercept. Emma Jaden. 0. But we usually make it a point, so 0 comma, wait a minute. 0 comma, what's that? Yep. 0 comma 1. Hey, pausing my video for a second. Okay, and next up is continuous. Is it continuous? Does cosine keep going? Yes. The reason we keep having to answer that is there's one graph that doesn't keep going. And it's tangent. I showed you a picture of it before. It's got these asymptotes. And you can't cross asymptotes. And so tangent just keeps on having to repeat itself. It does that, and then it stops. And then it starts over again and does another one of these. And then it stops at the asymptote, and then it does it again. And so anyway, tangent is the one that's not continuous. Sine and cosine are. All right, and then this is the ones and zeros thing. Cosine, is that the y? I hope that bothers you to hear cosine and y, because it should, because cosine is x. So then you go over here, it's the x values, and so it's 1, 0, -1, 0, and back here to 1. And notice 0 and 2 pi are like the same place, right? 0 and 2 pi are in the same spot, so it should be the same answer right here and right here, because 0 and 2 pi are the same thing. Kind of. All right. I feel like you're getting it. So then they do, I already talked about this, so I'm just going to remind you what I said. If there's a 2 out in front, do you get we can trust it and it makes it twice as tall? It's also where the amplitude is, and so then we'd say that the amplitude used to be 1, but now it's 2, so it's twice as tall. So any of my graphs that used to, look at how fast I can graph sine. Eventually, you'll be able to do that too. Okay, so that's sine. And if I want to make it twice as tall, I just go like, okay, twice as tall. In both directions, twice as tall and twice as low. Okay. And they say a horizontal shrink of a half would actually be a 2. The way I would like to say that is, a 2 doesn't do what you would think. It makes it half as wide. Because the stuff on the inside is about horizontal, which is about wideness, but the 2 doesn't make it twice as wide, it makes it half as wide. It's like compressed. So my graph that normally for cosine looks like a valley, it gets half as wide, so the valley just gets done like really quick. So then the valley goes like that. Gets the graph over with really, really quick. I know the colors are not great to be able to see that. I'll change that to, I don't know if green's much better. Change it to black, maybe that'll be better. So it got that graph done faster. It's compressed, it's half as wide. All right, we're almost to the last slide, which is good. Now, if I said to graph sine with a 2 here, it feels like it's a completely different question. But in my opinion, you just start, I do everything the same as normal sine. And again, I'm pretty good at this. I'm going to just remind you and go, is this cosine or sine that I just graphed real quick? That's cosine because it's a big valley. So that's not right. There's sine. And if I want to make it have a 2 here, then I just have to make it either, pay attention here, either go twice as high as it was and twice as low as it was, or I could just label this a 2. And then I can just leave the graph the same. It's kind of cheating, isn't it? See what I'm talking about? Like, I'm going to get cosine out of there. Just trying to make a point. Cosine's like a valley. Sine starts at 0. So we're doing sine right now. So there's sine. But do you get if I just change this label to be a 2, I'm saying it goes to 2 now instead of to 1. And therefore, even though the graph looks the same, it would be okay. Because how would I judge you on the test? I'd be like, did the kid make it go to 2? Yeah, because you labeled that a 2. Now, would I rather see this? I guess I would rather see that. It went twice as high and twice as low. Oh, I don't think I went quite high enough. Maybe I should make it even more pronounced. But if you labeled it with a 2, I would have to have accepted it the way it was. So it's actually easier. And I know a lot of people like to save time and save steps. You could just relabel this with 2s. And I'd have to take it. Okay. So here's 2 cosine. Remember cosine's the valley? So if I were you, I'd start by just making the valley. And then relabel it a little bit. Because all your y values are twice as big as they used to be. Because it's taller. So there's really just like graphing cosine and changing one thing. So start by graphing cosine. If you don't know anything else, just graph the valley. And then apply the 2. So cosine's of valley. Starts here, ends here. It's the lowest spot in the middle. I better figure out where the middle is then. I guess that's the middle. But Mr. Server, you forgot to stretch it with the 2. I'm going to cheat and just change that to a 2 and that to a 2. Wait, the bottom one should be a negative 2. See how fast that was? I didn't have to actually change the graph. If you really wanted to, you could make it twice as tall and go twice as low. And I'd be okay with that. But it'd been easier to just make this a 2 and this a negative 2. Did the domain change? No, see, still goes left and right, goes forever. Did the range change? Yeah, because it used to go from -1 to 1, now it goes from -2 to 2. Did the period change? Like how long a complete cycle lasted? Still stopped at 2 pi. Period's still 2 pi. Amplitude, 2, because of that right there. And the y-intercept, it used to be at 0, 1. Now it's at 0, 2. And I remember this. These are all 0s and 1s. Kind of. The cosine is the x, and so this will be a 1. And then the x here is 0. And the x here is -1. And the x here is 0. And the x back here again is 1. But you got to remember that you times them all by 2. It didn't actually go to 1, it went to 2. 0 times 2 is still 0. It goes to -2. 0 times 2 is still 0. And then this one goes to 2. Okay, that's a lot. Honestly, I looked at that and said, I'm not sure that we'll be able to get through that much in one day, but we did. Yay. So, let me show you on the worksheet. You only have to do problems 1. I think in the title of the worksheet, I looked at it like literally 4 days ago, so I'm not sure. Did I say to do 1, 2, and 3, or just 1 and 2? Or what did I say in the title of the worksheet?
1, 2, and 3.
1, 2, and 3. Okay. So let's do one together. Numero 1 on the worksheet. This is what's going to actually make it stick. Otherwise, you'll remember 10% of what I just said. Andres, can you read me number 1?
Graph y equals sine x over the interval 0 to 2x.
All right. 0 to 2 pi, probably?
Oh, yeah, 2.
Okay, good. No problem. And then I always start by figuring out how high I want to make it and how low I want to make it. And I gotta remember, is sine the one that's like Breckenridge? No, that's cosine. Cosine is the one that's like a valley. So sine is the one that starts here. And then I like to label where my 2 pi is, because I know it ends there. Sine I can do pretty well just as kind of a wave. But cosine, I always do it in 4 little parts. The valley for me is hard to do. Okay, I graphed sine. Did it tell me anything else in the directions, Anders, besides just graph sine?
Yeah, it says, what are the x-intercepts?
Okay, x-intercepts. And so that's, okay, I guess that's right here with 0, 0. You don't have to label that one. We all know what that one is. That one, though, Anders, do you know what's there? Right here?
Yeah, pi.
Pi, correct. It says only label the x-intercept, so I guess I don't have to label the other spots. In case you want to know, that'd be pi over 2, and that would be 3 pi over 2, but I don't think it makes you do, because they're not x-intercepts. And what else they want to know?
What is the period?
You tell me what's period.
2 pi.
Yep. And I did give you this little formula before. The period would be 2 pi divided by b. But our b term, there's no number in there, so it's just a 1. So therefore, it's 2 pi over 1. I just want to remind you, this is going to come up later. Period is 2 pi over b, but in our case, since b is 1, period is just 2 pi. Does it ask you for more, Anders?
What is the domain?
What do you say?
It said negative infinity.
Yep. Because it goes forever. Next thing.
What is the y-intercept?
Y int. And that's right there, and that looks like it's at 0, 0. What's the next one?
What is the amplitude?
What do you say?
It said 1.
We're correct. Because there's a 1 right there, and because the highest it goes from here up is 1. What's the next one?
What is the range?
What do you say?
I said negative 1 to 1.
Negative 1 to 1 is correct. Is there a last question?
That's it.
Yay, okay, good. I'm taking a wild guess. They're going to make you graph cosine. And then maybe the third one is like a stretch of something. All right. I feel like we made some progress today. And honestly, if you really understood everything today, that's like half the test. Serious. This is another short unit. But that means you don't have to really understand everything yet. If you feel lost, it's okay. It'll come together over the next day or two. As long as you stay with me and get your homework done.